And I will let you guys go, okay? Okay, so today this is introductions course, right? Introductions. This is introduction sections, right? So my goal today is I'm going to finish the slides, and I will let you guys go. Okay? So as I say, this course we are going to talk about the air pollution is solid. So first of all, for air pollutions. Sorry, give me a second. Okay, everyone. Okay, everyone. Okay, everyone, listen up. Okay, first question come to our minds about air pollution issues. How to remove sulfur and nitrogen oxides. Sulfur and nitrogen oxide from fuel stack gases. Okay, what does fossil fuels mean? Anyone know about fossil fuels? Anyone? Okay, fossil fuel including crude oil, coal, and natural gas. Okay, actually they are from the dead organisms. Okay, they are from the dead organisms. The ancient dead organisms, long time ago. Billions of years ago. Okay, and we know that in the organism we have sulfur and we have nitrogen. Nitrogen, sulfurs are very important element for amino acid, right? And those fossil fuel, you know fossil means, right? Fos, right? That means dead body. Okay? So if we burn those fossil fuel, that means we burn the dead body from the ancient animals and ancient plants, right? So we know burning is a rapid oxidation. So it will form sulfur oxides and nitrogen oxides. Okay. So normally we call sulfur oxide as salts and nitrogen oxide as NOx. And they are also the elements for SRAM. Okay, so later in this course, we are going to learn how to remove those sulfur oxide and nitrogen oxides. The second question is, it is impossible to remove all of them. So what happened with these gases? This gas means SOx and NOx. What happened with these gases get into atmosphere? Okay, so we call this second pollutions. As I say, the SOx, NOx will result in acid rains, and NOx will result in smoke, right? Photochemical smoke. So this is what we are going to learn in this course as well. And next questions, okay? Those pollution has been caused, has been generated, right? So how are air pollution problems transported, and who is going to be affected? I would say all the living things. Okay, even some buildings will be affected by the acid rain, right? And last questions. What impact do these emissions have on the natural waters and the aquatic life? I say this is going to cause acid rain, right? So the pH value will be lower. We call this acidification, right? So the pH value will be changed. The pH value will be lower. So this is probably not suitable for some aquatic life. People okay? Okay. So let me answer the third question. Who will be affected? I would say everyone and everything. Not just humans, including plant, insect, animals, humans, the whole ecosystem, and even our Mother Earth will be affected by air pollution. Okay, so next slide, I'm going to talk about some tragedies of air pollution. Okay, so about 100 years ago, okay, this happened in Meuse Valley, Belgium. Okay, caused by this so-called zinc smelters. And 60 people died. Okay, the reason is the emissions. Emission fails. In this case, because the areas and the weathers and cause the emission fails. Those smoke caused by those industries, toxic gases cannot be emitted and cause 60 people die. Okay, and the second one happened in the United States, in the Soviets. Okay, in 1948. So it's about the small. It caused 23 people died over Halloween weekends. And this, because of this tragedy, this one promote the Clean Air Act. Promote the U.S. government to set up this so-called Clean Air Act in the United States. Okay, the textbook we are going to use is written by American scholars. So we're gonna use lots of cases happening in the United States. Okay, of course I will add some cases happen around the world, okay, especially in Taiwan. Okay. And because of these tragedies, it led the US government to set up this so-called Clean Air Act. Okay, to prevent the public health caused by air pollution. Four years later after these tragedies, this happened in UK, England. Happened in England, UK. So this is the same as the small issues. The so-called grey smoke of London. In this one, caused 4,000 people died. So actually, it's around 4,000 to 12,000 from the records. Okay. 4,000 to 12,000 now. Okay, so this is the Clean Act in United States. Okay, and these tragedies caused the same name, also called Clean Air Act in UK. Okay, Clean Air Act 1956. So it's so-called Clean Air Act 1956 in the United Kingdom. Okay, last one happened so 30 years later, this one happened in India. So this so-called methyl isocyanates, so so-called MIC. This is very toxic chemicals. This is highly toxic chemical gases. Okay, so this due to the gas leak, 2,000 people died. So this case tells us the safeties in chemical industry, the risk management, so as chemical engineers, your abilities, your responsibilities is not just making those chemicals. You are also responsible for the safety and the risk management. Understand? This is even more important. If you make less products, you just make less money. But if you cause those tragedy, your company may bankrupt. Okay, your company will bankrupt. 你的化学产品产的少，只不过你赚少一点钱而已。可是发生这种事情，你的整个公司就倒闭了。Understand? So as a chemical engineers, you are not just have ability to produce a better product. You also have the responsibility to control those risks happen due to chemical hazards. Understand? That's the importance of environmental engineers. That's the importance of environmental engineers. Okay, next, I want to differentiate the difference between the primary pollutant and secondary pollutant. The primary pollutants means those gases or those chemicals, they are discharged directly into atmosphere. Okay, so they are just like low products. And secondary pollutant means after those chemicals discharge into atmosphere, they cause some chemical reactions. That's so-called secondary. OK， 所以比如说二氧化硫或一氧化氮直接放到空气中，这个我们叫 primary， 然后在里面形成酸雨，我们称为 secondary. Understand? So those, for example, like SOx, like NOx, they are discharged directly. Okay, the key word is directly. For example, like SOx, like NOx, directly into atmospheres. It's called primary. Okay, for example, like CO, like SOx, like NOx, or even some volatile organic compounds. They are so-called primary pollutants. Okay, and secondary pollutant means they cause those chemicals have some chemical reactions. Okay, those chemicals have some chemical reaction. Cause, for example, like cause the photochemical smoke, like acid rains. Okay, for example, like NOx. If NOx react with volatile organic compounds, okay, and with sunlight here, it will cause ozone. It will produce ozone. So this reaction is so-called secondary. So this guy is secondary. These two guys are primary. Understand? So NOx and volatile organic compound, they are so-called primary pollutants. And ozone is secondary pollutants. Okay? Okay? So, why is air quality such a problem? Okay? Why is air quality such a problem? I would say, actually, air pollution is a silent killer. Okay, actually, it's a silent killer. You are suffering. For example, like today, if today the quality of air is not good, but you will not notice. You will not notice until you feel very uncomfortable. Okay, so poor air quality can lead to, first one, the smoke. So why we call it smoke? Because is a mix of smoke and the fog. Okay, and the poor air quality will also cause the respiratory and some disease. Okay, for example, like what we were going to learn later is like PM 2.5. P stands for particulate. M stands for matter. So it's particulate matter. 2.5 is the size. The 2.5 means 2.5 micrometer. So some sulfur dioxides will be coated on this particulate matters that enter your lung. Okay, and you have some water, moistures, right, in your lung, right? So it will cause some acid drop. So it will damage your lung. For example, one example here. We're gonna talk about this later. Okay. I just illustrate one example here. Okay, so it will cause your respiratory and even some other disease, like asthma. Okay, and like some heart issues. Okay. The acid rains. The SOx will cause sulfuric acid or sulfurous acid. NOx will produce nitric acid. Number 4, global warming caused by those gases like carbon dioxide, like methane, like dinitrogen monoxides. Okay, it causes something called greenhouse effect. Greenhouse effect. Number 5, the last one is called ozone depletion. Depletion means consume. Okay. Depletion means consume. It means break a hole. Okay, in our ozone layer. It's caused by CFCs. So UV will increase. Okay, the UV reach our surface, the surface of Earth will increase. It will cause skin cancer. It will cause skin cancer. Okay? So some country, but I would say that in Taiwan the air quality is not so good. Okay? So I received my education in Canada. We also have an international from Denmark. I think that, for example, like I will show you like this. Okay, this is a photo taken by me when I were in Canada. Okay, this is Toronto. Okay, so the air, I would say in Canada, okay, the quality of air is pretty good. Okay, so this is on the campus of University of Toronto. Okay, this is my wife and my baby girls, my daughters. Okay, and this is Rocky Mountains in Canada. This is Rocky Mountain in Canada. The air quality is pretty good. Pretty good. You might also share the air quality in your countries. That is, okay. Okay, we will also learn about this, but today I will just give a quick talk, okay, about the acid rains. Okay, so the main integrants is sulfur dioxide and the NOx. Sulfur dioxide and NOx. Okay, and the product will be sulfuric acid and nitric acid. Okay, the product will be sulfuric acid and nitric acid. Okay? So there are two kinds of deposition. One is called dry deposition and also wet depositions. When those things become waters, okay, and come with rain. Okay, so this is the map showing the global acid depositions. Okay, so the red one means the current province areas. Okay, and Taiwan is here. I think Taiwan should be red as well. Okay. Okay, so this is greenhouse effect. Actually, greenhouse effect is the natural phenomenon. It's a natural phenomenon. But we human beings make it worse. Okay? Without greenhouse effect, for example, without greenhouse effect, the temperature right now probably minus 30 degrees Celsius, even lower. We human beings cannot live here. Okay? Due to greenhouse effect, the weather is suitable for human beings. But how come the greenhouse effect becomes global warming? Because we produce lots of carbon dioxide, makes sense, and some greenhouse gases. We make it worse, and it causes global warming. So the temperature raises up. Do you understand what I'm talking about here? Greenhouse effect is the good guy. But we made this good guy become a bad guy. The bad guy is global warming. You know what I'm saying? 懂吗？如果没有 greenhouse effect 呢，我们现在温度在零下20-30度。可是呢，因为我们产生很多这工业的气体，所以温度上升了，变成 global warming. Understand? So, I remember I asked one questions. Okay, I remember I asked one questions about the difference. Some students, or even some book, they put the equal mark. They put an equal mark for greenhouse effect, global warming. Actually, they are not. They are not. I would say global warming is enhanced greenhouse effect. Okay, because as I say, greenhouse effect is a good guy. Okay, it's due to the heat from the sun get trapped inside the gas of greenhouse and heat up its air. So the temperatures is suitable for human beings. But we human produce some carbon dioxide, for example, like carbon dioxide, like methane, enhance greenhouse effect. And this enhanced greenhouse effect become something called global warming. Global warming. Okay, so global warming means the increase in the average air temperatures, average temperatures of the Earth. Okay, so let me give you a numbers. Let me give you a number. Without greenhouse effect, without greenhouse effect, the average temperatures on Earth will be minus 18 degrees Celsius. So with greenhouse effect, the average temperatures is around 15 degrees Celsius. You can see a difference, almost 30 degrees Celsius difference. Without greenhouse effect, I think most of people, some area, like Canada, okay, you cannot live there. Okay, without greenhouse effect. Understand? And with greenhouse effects, the average temperature raises up to 15 degrees Celsius. It's suitable for a human being to live. But the problem is, we human beings make it worse. Okay? So that's the reason I say that the global warming is something called enhanced 加强的 enhanced greenhouse effects. Okay, so the human beings, the scientists, and the government all around the world notice this. So they gathered together and set up this so-called Kyoto Protocol in 2005. Okay, in 2005. So the target is to reduce 4.5% greenhouse gases, including methane, CH4, carbon dioxide, and nitrogen oxide, it's dinitrogen monoxide. And not just that, also including hydrofluorocarbons. Okay, perfluorocarbons. And also sulfur hexafluorides. Try to reduce these 6 kinds of greenhouse gases, 5.2% per year. Okay, finish. Okay, so next one. So these 3 scientists will award Nobel Prize in chemistry in 1995. Okay, because they found out the CFCS, okay, can last 10 to 100 of years in atmospheres. Okay, and the ozones, okay, because they can cause some free radicals and will generate the chain reactions to break down the ozone. Okay, so they found that CFCs will reduce ozone. Okay, and they got this proof in 1985 and received the Nobel Prize in chemistry in 1995. Okay, so the concept is, let me write down here. Okay. Okay, let me write down here, then we come back to you. Okay, here. Okay, number one, okay, everyone okay? So CFC is released, okay, and rests into the ozone layer. So CFCS will react with the radiations, the sunlight radiations, the sunlight. Okay, and it will release the chlorine-free radicals, the chlorine-free radical. And this chlorine-free radical we know that this free radical is very unstable. Because it's very unstable, so this is very reactive. So this chlorine-free radical will react with ozone. Okay, it becomes ClO plus oxygen. It will break down. Okay, it will break down. ClO free radical and ozone. Okay. And understand? And this ClO free radical will also react with O. With O. Oxygen atom. Oh, sorry. ClO free radical. And it will cause some so-called chain reactions. Chain reactions. So it will cause chain reactions. The chain reaction means it will continue. The chain reaction means it will continue to break down the ozone until something called terminations. I think you know this in organic chemistry, right? So ClO free radical in contact with ClO free radical become ClO2. Okay? Let me put chain reaction here. So this is initiations. So initiation is the CFCS like freons. Okay, for example, like the product name is freon. Will be broken down by sunlight, by radiations, and generates chlorine-free radical. And we know free radical is very unstable. That means it's very reactive. And next step is so-called chain reactions. Chain reaction means it will continue and continues. The chlorine free radical will break down ozone. And become oxygen. Until the free radical encounter free radical. So this is called termination step. Okay. So in 1974, these three guys proposed this idea. The CFCs will break ozone layers. And in 1985, proof. Okay, this happens. So in 1987, the government around the world set up this so-called Montreal Protocol. Okay, Montreal is in Canada. Okay, Montreal is Canada. Montreal is a capital city of Quebec. Quebec is a province of Canada. Okay, the capital of Canada is not Toronto. Toronto is not the capital. Actually, it's Ottawa. Ottawa is the capital city of Canada, and Montreal is the capital city of Quebec province. Okay, and in 1985, these three scholars won Nobel Prize in chemistry. Okay? Okay, so this slide defines the air pollutants. So air pollutants means a non-substance in the air that can cause harm. Not just for human, but all the living things in our environment, in our ecosystem. Okay? Okay, these are the four major air pollutants that we need to take care of, including nitrogen oxides, sulfur oxide, carbon monoxide, carbon dioxide. Carbon monoxide caused by burning fossil fuel. Burning fossil fuel. Carbon monoxide caused by incomplete combustion. And carbon dioxide, of course, caused by combustion. Combustion here we mean the hydrogen hydrocarbons react with oxygen and produce carbon dioxide and water. Okay, let's continue and let me finish this slide and I will let you guys go, okay? Okay, nitrogen oxide caused by burning fossil fuels. Sulfur oxide as well, caused by burning fossil fuels. Carbon monoxide caused by incomplete combustions. And combustion means the reactions of hydrocarbons with oxygen cause carbon dioxide and water. Okay, and those pollutants come from two sources. One is called stationary sources. Okay, stationary means not moving. Okay, and 40% of the air pollution caused by stationary source. Okay, stationary means not moving. That means fixing. Not moving. Okay, fixing or not moving. 固定的。Okay. Okay, and you don't need to memorize those numbers. And also, my exam is open book. Okay, so you don't need to memorize formula. You don't need to memorize the number. What you need to memorize is the concept. Okay, understand the concept. You just need to understand the concept for this course. 你只要了解观念就好，其他都不用背。Understand? Because it's open book. Okay, it's an open book exam. So what you need to do is understand the concept. Okay, the next one is mobile. Okay, mobile means moving, right? So 60% of air pollutants actually from the mobile sources. Okay, everyone okay? Okay. Okay, everyone okay? Okay. So, what are effects of the air pollution? So it will damage. So it will damage human health, okay, including respiratory. Cardiovascular, 心血管, and also our welfare. Okay, it might also damage our buildings. Okay, and it will damage vegetation and animals. Damage the materials, even the structure of buildings. It will damage our atmosphere, soil, or even our drinking water. Okay, so damage. Okay, so as I say, the air pollution is a silent killer. It will affect us, but you do not notice, right? So including the respiratory effects. I already mentioned it. 呼吸系统, and also our cardiovascular. Cardio is heart. Okay, some heart issues. Okay, finally, okay, the quick grips. How do we reduce air pollution? Okay. So something I want to mention here, but more advanced technology I will mention later. For example, like you guys know, like hybrids. Hybrid means mix of oil and electricity. Okay, all electric vehicles like Tesla, right? And we might also use some alternative fuels. Okay, some alternative fuel like solar energy. Okay, like wave, like wind power, right? So we also mentioned this. And I think this is a hot topic. Some of professors in our lab are also doing this. Okay, the carbon sequestrations. Okay. And as I say, actually those pollutions caused by human beings, right? So how to refine, how to control human beings? You need to make regulations. Okay, you need to make regulations. So in this course, we will also talk about some law. For example, like Clean Air Act. Okay, some regulations in the United States and compared with the regulation around the world, and also the regulations set in Taiwan. Okay. And as a student, you say, "Oh, I'm just a student. There's nothing I can do." Okay. As a student, or as a student, what you can do is, you might do car tours, or you might just work, or you can use bike. Instead of use those fossil fuels vehicles. Understand? Okay, so that's pretty much of today's. So starting from no class next week, keep in mind, no class next week. Starting from the week after next week, we are going to talk about the technologies that we are going to apply.